Sorry about that. Okay, so for the agenda that we're going to have, just a quick introduction of what we're going to see. First, we're going to have an introduction and context, then methodology, then we're going to go into the product with a demo, a live demo, and then we're going to go into impact and next steps. So this presentation is actually not as technical, and I'm going to go deeper into the product. Just a clarification. So without further ado, let's do the introduction and let's talk about the artificial lighting and the bats. Like, we all know what we are solving here, but some of the facts that we found in our literature research is that 1/3 of the bats are actually in danger of being extinct in the last few years. And this affects also, well, first the life of the bats and then the biodiversity of the other species. So one of the proposals from the academics is build dark ecological networks in order to solve these problems. And in taking into account that, we have our objective, right? And our objective is create a tool that helps the decision makers create dark ecological networks between bats activity areas, right? And how do we do this? We divided this objective into two main parts, right? The first one is build potential dark ecological networks, and we do that first by identifying bats activity area, and then once we have those activity areas, we connect the bats, those areas with potential corridors. So then we have potential corridors, and we go into the second step, which is choose the best dark ecological networks. And we do that by measuring the impact of implementing each corridor. So, and well, another thing that we thought about when we built this product is what are the key components that we need in order to be successful. So the first thing that we need to take into account that it needs to be a solution that is holistic. What does it mean? That it takes into account both, of course, the impact in bats and moths, right? And in like the animals that we are evaluating, but also we need to take into account the impact in the citizenship. And this is something that the solution must have. The second one is flexible, and I apologize because now I realize that the second column is wrong, but what I mean with flexible is that we want to take a solution that the actual decision makers can modify with their knowledge of the field, and they can modify the parameters and see what the best solution is. Because, of course, I'm not a biologist, and neither are my other teammates, so we did want to make a tool that was flexible enough for them to do that. And then the third one is scalable. It needs to be scalable to other species that are affected by light, and also to other cities. So to talk about the methodology, I'm not going to go deeper into like the actual method that we use, but I do want to go into how is our solution holistic and flexible in terms of the methodology, right? And we do that with the cost function. What we do is basically, in the methodology, just to give you a quick glance, is we take all the city of Bristol and we divide it by hexagons, right? And we want to build the potential dark ecological networks. And with the cost function, what we are looking for is to calculate the cost of a specific area being included in a dark ecological network, right? So taking into account that, we build our cost function that you can see in the right? So we have two main components, and then we have a weighted factor. So let me go first into the two components. First is the bat resistance. What is the bat resistance? The bat resistance is what is the cost for the bat for going through that area. So for example, we take into account the percentage of buildings. We don't want to have areas that have a lot of buildings, right? So we want to diminish that. At the same time, we do want to take into account places that have a lot of nature where the bats can go by. So for example, rivers and green areas, etc., right? And the second component is the human impact. So how is it impacting the human behavior and the citizenship behavior, right? So we take two main components, right? We want to keep the perception of safety because we are decreasing the lights. So we do want to take into account those factors, right? And we also take into account points of interest where we cannot definitely diminish the light. So for example, hospitals or something like that. And then we have alpha, which is the ponderation factor between resistance and impact. And having said that, I'm going to pass it to David. So he's going to show us a live demo on the product.
Thank you. This is the demo, right? So I guess we can queue now to the demo. And just keep in mind that what I'm going to show you is a live demo that is on the internet right now. And you could actually go to the address and see it.
Bear with us a little bit because we have to change screens.
All right, it's there. So this is a proof of concept of what the decision makers will be able to see and interact with to see in the tool. The first thing that you'll notice is that you'll be able to, you see this parameter that we're changing, that can change. That is a parameter that indicates, in this case, the weight factor between how much do we weight the either resistance to the bats or the impact to the humans. The important part is that you can change it and see how it actually changes the actual network that is displayed. The other thing that's really important is that on the right you can see, you can quickly assess the impact of state solution. We're going to go into a little bit more detail about the impact later, but just keep in mind that two things. You will see how this changes, how the network changes, and you see how and you will see the approximate impact of this proposed solution. Now if we go down a little bit, you can see different maps. And these maps, it's because for me it's delayed. You'll be able to see different maps of the actual attributes that are inside these cost functions. One thing to keep in mind is that the cost function itself, these two main components are both flexible, and this is one thing that we want that in the future we will include, is that to include changes in all of these different parameters. Now, how does the expert use this? He will see these maps and say, okay, if I want to weight more, for example, rivers, I can predict more or less how the network will change. Now with this is the demo. Let's go back to the slides and talk about the key components, how they fulfill them, and talk about the impact. So the first thing that you notice is that we have shown that this solution is both flexible and is holistic. You can actually interact, like say how holistic it is based on how you weight these factors, on how you weigh a cost function. And technically, the solution is also simple enough that it can be transferred and used in other night-dwelling species. Now for the impact, oh, I have to go.
Yeah, we pass the time. It gets back.
Okay.
There you go.
It's already in the... I just talk about this, so I'm going to skip it. And about the impact. Of course, there are two things we're impacting. One is the bats, and what we want here is to give them more area, and it's important to have like connected area because this will give them more opportunities for foraging, and the increased area will also allow them to expand their population and flourish. And of course, there is the impact to humans, which there are drawbacks, such as the perception of security, but also there might be potential benefits of the dark ecological network, such as a reduction in costs. This is what you can actually see on the, if you recall to the demo. Of course, the particular impact of a proposed solution depends on the parameterization, but if you recall to what we show in the demo, the first scenario had around 3,000 hectares of area for the bats, and you could assess a potential impact on human safety by checking how much, on average, you should reduce each light, which it was a relatively low number of around 20%, if I'm recalling correctly. So what goes from there? What goes from here is the next steps, and is to show this to the experts and validate that this is a tool, validate how we can fine-tune this tool and how we can change the cost function in order to adjust it better to their needs. For example, if there are more features or factors that they might want to include. And with this, we can go on thinking on how to productionalize how to move into production. And I should recall here that the solution right now from what you see on the demo, the step for going into production is relatively simple, since most of the components in the back are already there. And of course, there are technical improvements, such as if we had that step mostly, if we had better data. For example, we could, if you notice, we did not include the time. But if we have like more accurate data for the timestamps, we could include that also to change the optimization and change the cost function accordingly to the time.
Thank you very much. Your time's up. So now we have some time for questions.
Sorry.
Do I have to do something? No. So I have a couple of questions. I think, and I apologize if I read incorrectly in your notebook, that you used satellite images, or you tried to use satellite images. So my first question is, why did you use them, and what benefits you think satellite image brought to the algorithm, or if you use them? Go ahead, and then I'll ask the second question after. I think it's easier.
Okay. The main thing that we got from the satellite image was an estimation of how much you should reduce the light. And there could be like two ways we tried to approach this. One was to use the actual points of the actual lights, but then we had to take into account, okay, which type of light is this, how it will reflect, in order to actually estimate the pollution would be like super difficult. So we said, okay, what if we look it from the sky, and then we just see how the actual light pollution is looking in the city of Bristol from the sky. So in a way, it simplified a lot the whole process of calculating how costly and how much should you lower the light in order for the bats to be comfortable, which is included in the impact function to the human, because that's the main component. You should lower the light enough for the bats to be able to like dwell in the place or even cross.
So you suggest to use satellite images as one of the data sources?
Yes.
Yeah.
Great.
Just to add on there, this is something that we saw in another paper that was implemented for other bats and was successful. So we thought, this is clever, this will save a lot of time, and like it has shown results, right? So that's why we also took it.
Good, awesome. My second question is, so I saw that you have already a sort of a prototype application, that it's more close to the production, I would say. But how do you ensure that you measure data drift, concept drift, and model drift, that the outputs that you generate actually are, accurate?
Yeah, well, we are not actually predicting, right? We're using an optimization algorithm. So I don't think we will have problems. Like maybe data drift is something that you will use more on a machine learning problem. We are using more of a linear optimization approach, right? So in that concept, I don't think we need to be as careful as you will be in machine learning, right? If you want to add something, David?
Yeah, there is actually, for the expert of what you will see on the product, you can assess based on your expertise if something makes sense once you change the weights, because as you recall, you can also see the maps of the different spatial distribution of the features that conform your cost function. You will be able to fine-tune this cost function, and then you can say, okay, I will probably change the weight of this. This will impact relatively. This is what I'm thinking. This is how I'm thinking it will impact the network, and you can assess and change accordingly, like fine-tuning the solution.
Thank you. Understood.
Thank you. Congratulations for the presentation. I really liked the data visualization part. Like it looks super user friendly. I also appreciated like all the KPI because really like this, it's quite clear. Like you have several elements to take decisions, urban decisions. And on this element, I was wondering if you had in mind other KPI that you could add, but that are maybe less obvious or less or more complicated to aggregate or to create.
Yes, there were actually many KPIs that we tried to see how we could calculate by looking a lot into the research. One of them was, for example, certain thresholds of light affect the relative activity of the bats. So we wanted to find these thresholds, but at the end it was kind of difficult. So we said, okay, I guess to also make the tool simple, let's keep the area. we know that we also justified how much the light should we lower, and that's of course in the notebooks, but we perhaps could go to the appendix if you want to go into that. But yeah, I forgot what I was saying. Sorry.
And yeah, I guess to add on that, I think, as you said, the product, we envisioned it as super user-friendly, right? And therefore, I think we didn't want to include something difficult to understand, especially for someone who's not like comfortable with the methods behind it, but more of a, like, I want to know the solution. I guess like an iteration to the product will be, we're not experts, again, neither on bats nor on like city planning, right? So maybe taking such specific metrics into account, and actually we can also add them to the cost function. It will be quite easy to do, and also that you can include it in the tool. So like it's more knowledge focused, right? But we did what we thought was best with our small knowledge of the bats and the city planning.
Thanks. If you want to enrich this, go in depth into discussion, maybe I would recommend to have a look at Vibe Lab. It's a laboratory based in Amsterdam, and they're doing great job really in night life analysis.
No, nice.
So they're
Nice.
really nice for
for the
this.
recommendation.
Thank you.
Something in the demo we didn't show that we do have different layers also. We do have some on top of the activity that we were displaying and visualizing. We do have light, and it's quite intuitive for an expert to show the barriers that there is a kind of gap between the potential gaps between the activities, the cluster activities, and something that also we were thinking about next step is to understand actually the activity types, like stratified, because due to the nature of the data, that there is no timestamp, we couldn't understand some peaks and to infer if we are talking about roosting or we are talking about commuting or whatever the activity, and we assume that there is a change on the behavior due to the Alan. So yeah, I was going to say.
Hello. So, nice presentation. I really liked the fact that you made it very visual. So one thing I did not fully understand was in the notes that you got before. I got the idea that once you run the minimum spanning tree, and it seems to be like a common trend in all the groups, you may end up with a disjoint graph where you have an area in one side of the city that's connected and another area in another side of the city that's connected. But in the example you gave here, it seems not to be disconnected. So it was fully connected. All the regions were connected. So do you impose fully that it's connected, or you don't impose that?
It could be a different scenario that we run. It could be disconnected because you can also filter before some branches that you don't want. For example, if they're really far away. So perhaps it was like a different scenario that we run. But it tries to connect, like, you could put some, like once you have like all the connections, you say, okay, I don't need all of these, be redundant. Sometimes it might be like too far away, 2 points, and you say, okay, bats are not going to travel 10 kilometers. They mostly go, at least the horseshoe bats travel kind of 2 to 3 kilometers around their roosting. Since we didn't know, for example, the roosting, we say, okay, 2 kilometers to everything. And the thing is that you could.
So that's an option you can choose in your algorithms.
Right now it's not implemented, but it's something that we included in the notebook and in the analysis. Like you could filter by some parameters before, like we did filter those that had like very high costs at the end. Even if there was the shortest path, that it was like super costly, we say, okay, this doesn't make sense.
And just to clarify why it is connected, I think, and correct me if I'm wrong, Becky, but I think like in the surroundings of Bristol, there are some parks, right? So like that makes the path to go as it goes. But like in the top, we have Dijkstra, right, shortest path, and then on top of that, we have all the potential paths that you can have, but then we optimize for what's the best according. So like you may have, I don't know, 1,000, the combination, right? And then you will extract which are the best ones. So it may be connected or not.
To that, there are some points that are activity areas that could not be connected because they were surrounded by, like really, for example, a bunch of points of interest. So there was no path going up.
Okay, yeah, that's
the idea was more to kind of provide the KPIs for the expert and decide, give them the opportunity to evaluate their scenarios and decide if it's something feasible or not.
Okay.
So,
So you give
could
the
be-
option of to the user to adjust his alpha
Yeah.
weights,
And-
bat friendliness with
And
user
also-
friendliness, but the inner weights in these two terms, they are fixed, right?
Now, so, okay, right now they are, right, because this is a POC and we didn't have the time. What is our idea? Idea is that actually, like, the platform can have all the parameters parameterizable.
Mhm.
So experts can, like, we did our best to estimate some weights,
Yeah.
right? But we do want them to be flexible. So we did show, like, the change in alpha, and we did actually, like, pre-parameterize, so it doesn't have problems when it runs. But the idea is to have, imagine all the parameters with the sliders, so you can change it, you can run it, and you can evaluate.
Thank you.
Thank you.
I don't have any questions, but thank you very much for your presentation. It's really interesting, and yeah, I think just in terms of visualizing how we could apply that, I think it looks like a really user-friendly solution. So thank you.
Thank you, Becky.
Thank you very much.
Also have the same comment from Gitty, that she has a compliment for first the optimization of more bat areas, and that they are shown the dark corridors actually there. And actually her only question is where can she find the demo, because she's interested for Utrecht.
Yeah, we can send the link.
Mhm.
It's an URL, but it's we have it on Discord, so we can send it. And
Okay,
she can
then I'll share it with her later, and then she can
Yeah.
play around. Perfect,
Sure
perfect.
thing.
Any further questions? No? Well, thank you. Big round of applause for GeoNEAS.